Okay, now we're going to look at a converging mirror. So for the converging mirror, once again I have the object. I've got my principal axis drawn. I have my mirror drawn with a vertical line. Notice I just have the edges showing which way the mirror is curved. That's the simplest way to draw a converging mirror. And so now let's get to work. Now one thing you'll notice is I drew a fourth ray name, a C ray. And so I'll get to that after I do the first three. I will do the C ray as well. So we'll start with the parallel ray, as always. Start at the tip of the object. Use a straight line. It's very important when you're doing these to use a ruler and make sure you are as careful as you possibly can be. So the parallel ray goes parallel to the principal axis and reflects through the only, because it's the principal and the secondary focal point in the same place, reflects through. So there I have my first ray, my principal ray, or parallel ray. Then for my next one, I will do the focal ray. So the focal ray will start at my tip of my object, go through the focal point, and reflect back parallel. Now you look at my drawing, you say, oh, Richard did not draw his line long enough, or didn't put it in the right place. But that's okay, I'll just go back to the first one I drew and extend its length, and I think we'll be fine. Okay, and so we have the two rays, they meet. Let's go for the third ray being the vertex ray. So the vertex ray is going to do red here. Goes from the tip of my object to the vertex, and then it's going to reflect back the same way. So look, I was 1, 2, 3, 4 bricks up. So I'm going to go from where my object is 4 bricks down, 1, 2, 3, 4. And it's going to have to go through that point for the reflection. It's going to be symmetric because we have the law of reflections. And so there I have my vertex ray, and then I have the final ray. The C ray means the center ray. What is the center ray? The center ray is a ray that starts at the center of the mirror. The center of the mirror, it turns out, is twice the focal length. It goes to the mirror. I can't even hit the mirror with this. That's okay, because when it hits the mirror, it reflects straight back because it's at the center of the mirror. And so now that one was not right. And that jumped it for me. I didn't want to do that necessarily. That's also not right. I'm just going to start right here. So the center ray should go like that. So now with these rays, I have all 4 of them meeting at essentially one place. And of course, if I drew this perfectly, they would all be meeting at the same place. And so my image is at the location where all of these meet. And because there's not perfect, there's a whole bunch of places. I just try to choose one that looks to me to be representative. And so I'm going to go with, that was not representative. Okay, to me that looks fairly representative. So that is going to be my image. Typifying that image, it is inverted. The rays really came together, so it's real. And it is enlarged. So this is how I constructed an image for a converging mirror if the object is farther away than one focal length. Now notice the center ray. I didn't talk about it carefully. We have a rule for mirrors that the focal length is equal to 1/2 the radius of the mirror. So that means the center is at the radius and the focal length is half of that. So there's a simple relationship between those two. because angle of incidence is equal to angle of reflection, by definition, if you start at the center of the circle and you go to a spherical mirror, it's going to reflect straight back to the center again. So that's why the center ray goes out and comes directly back on top of itself. So with the mirrors, you actually have 4 rays you can use. Now on the test, I'm going to require that you use 3 rays. You can choose any 3 of these 4 rays. For myself, to make life simple, I always do the parallel, the focal, and the vertex ray because I can do those whether it's a lens or a mirror. But if you prefer that center ray, that's your prerogative as long as it's a mirror. If it is a lens, you don't have that center ray, you can't do it. Now this here is a construction for if the object is farther away than the focal length. Now if the object is farther away than the center, it's still going to be inverted, it's still going to be real, but if it's farther away than the center, it's going to turn out to be diminished instead of enlarged. But let's look at what happens if my object is closer than the focal point. I forgot to label here, so let's put F and C. I didn't label C here either. So let's draw our rays here for an object that is closer than 1 focal length away. So once again, going quickly, my parallel ray. And because I know that, well, let me do the next one, then we'll come back to this one. So my focal ray, well, the focal ray, just like before when I was inside the focal point, I just start as if it started at the focal point and go through the tip of my object, and then that focal ray should reflect out parallel. And you can instantly see, hey, those aren't meeting. That is my focal ray. Let me put some dashes in for the extrapolated portion. That focal ray is not going to meet my parallel ray. So what do I do in that case? I have to make extrapolations. So I'm going to take my rays and extrapolate them out. Let's put dashes on these to make it clear that these are extrapolations. And we can see where the image is going to be formed. Well, that's only 2 rays. I can do a total of 4 here, so let's do the other 2. The vertex ray. For the vertex ray, I'm going to start at my object, go to the vertex. Once again, that object is 4 tall, so it's going to come down 1, 2, 3, 4. It's going to hit this point here. And so it goes like that. Let's take the extrapolation the other direction. And finally, for the center ray goes from the center like that. Now, putting the extrapolations on this part here, actually no, that wasn't an extrapolation because it reflects back that way. The extrapolation is out here. And for the vertex ray, the extrapolation was out here. And so we can see now where our rays have gone. The light rays are shown now. You can see where each one goes. But where's the image? Out here. When I look at these, it looks like 3 of them are very close to each other. So I'm going to take those 3 that are very close to each other and say that's probably where I should have my true image. And so, now actually, I have these three here are the good three, in my opinion. So there is some judgment here. Obviously, you want to draw the very best, most accurate image you can, the ray drawings, but you have to keep in mind that nothing in life is perfect. You know, I'm trying to use square blocks to do this. I do have a ruler tool that makes straight lines, but it's not going to be perfect. You want to be as accurate as you can, and you should be very close. And very close is going to be good enough for our purposes. So here's my image. This image is upright because the arrow is the same direction as my object. It's virtual because it's the extrapolated rays that meet, and it's enlarged. I'm sure by now it's going to be a broken record, but this upright and virtual go together. If you have an object that is closer than one focal length from a converging mirror, you're always going to have this situation, an upright, virtual, enlarged image. So we had two different types of images from the converging mirror, one that was real and inverted, one that was upright and virtual. Just like with lenses, we had two possible options. If you're closer than the focal length, you get the virtual one. If you're farther than the focal length, you get the real one. So that ends our tutorial on converging lenses.